Hello everybody, and welcome to example 2 on page 4 of the workbook. And in this example, we're going to introduce one more matrix operation, matrix multiplication. Okay, so this example is starting us off with two matrices, A and B, and it's asking us to do three calculations starting with the product of the matrices, the matrix A times the matrix B. Okay, now some of you may have seen matrix multiplication before. For others, this might be brand new. Okay, so this is a little bit tricky the first time you see it, so we're going to describe this very carefully. And just to warn you, this is hard to do on a screen recording, and so I'm going to do a lot of erasing and revising as we go through this. I think that's the only way to make this presentation clear. Okay, so with that in mind, let's start with the first calculation of A times B. We'll go ahead and write out our two matrices. So we've got 0, 1, negative 1, 2, 0, negative 2 times the matrix 1, 2, negative 3, negative 1, 0, 1. Okay, and for those of you who've seen matrix multiplication before, you might remember that this has something to do with taking rows of the first matrix times columns of the second matrix. So we would start by taking the first row of A and the second column, or I'm sorry, the first column of B. And what we're going to do is to take the dot product of that row times that column. Okay, so in particular, how does the dot product work? Well, we would start by taking 0 times 1. Okay, so I'm going to write that down, plus 1 times 2, that's 2, plus negative 1 times negative 3, that's 3. And that 0 plus 2 plus 3, that's going to be the entry in the first row in the first column of our product matrix A and B. Okay, now clear away the clutter here. Okay, so I'm just going to try to erase all of the markings that I did and just go back to the matrix that we started with. 0, 1, negative 1, 1, 2, negative 3, and we're going to start again. And this time we're going to focus on the second row of A and the first column of B, and take the dot product again. Okay, so 2 times 1 is 2, 0 times 2 is 0, and negative 2 times negative 3 is 6. Notice that gives us the entry in the second row and the first column of our product matrix. Okay, and we keep doing this. Okay, so let's clear away the markings that we did again. Okay, so let's see, we had 2, 0, negative 2 there, and 1, 2, negative 3 there, and we'll start again. Now we're ready for the entry here that's in the first row and the second column, and so we're going to take the first row of A times the second column of B. That's the dot product that we need. Okay, and so we'll go down the line again just like we did before. Okay, starting with 0 times negative 1, that's 0, plus 1 times 0, that's 0 again, plus negative 1 times 1 is negative 1. Okay, and then finally, okay, back to our original matrix again, 0, 1, negative 1, negative 1, 0, 1. Okay, we're ready for this entry. That's in the second row and the second column of our product matrix, so we want to take the second row of A times the second column of B and take the dot product of those two things. So we've got 2 times negative 1 is negative 2. Okay, then 0 times 0 is 0. And then finally, negative 2 times 1 is negative 2. All right. And now let's just simplify that. So let's see. We've got 0 plus 2 plus 3, that's going to give us a 5, and then 0 plus 0 minus 1 is negative 1. Okay, 2 plus 6 is 8, and then finally negative 2 minus another 2 is negative 4. And so this matrix right here is the product A times B. That's the result of our first calculation. Okay, now we can make kind of an interesting observation about size comparisons of these matrices. Let's look at the dimensions of each of our matrices. So starting with A over here, the very left, A has 2 rows and 3 columns. It's a 2 by 3. And what about B? Well, it has 3 rows and 2 columns, so it's a 3 by 2. Notice that these two numbers agree with each other. It turns out that to multiply 2 matrices, we need those 2 numbers to be the same. In other words, the number of columns of A has to agree with the number of rows of B. Okay, and then finally, another thing we can notice is that the 2 and the 2 here, that ended up giving us the size of the product matrix. We've got a 2 by 2 output matrix over here. So it's these 2 numbers, the very first one and the very last one, that tell us the size of our product matrix, as it turns out. Okay, so this is the first time you're seeing it. This is kind of a complicated definition of multiplication, but this will get easier as we do more examples. Let's move on now and see if we can calculate the other products here. Okay, so the next thing they want is AB transpose. Okay, well the thing is, we just calculated AB, and so all we need to do is to take the matrix that we came up with and transpose it. Okay, so reverse the rows and the columns. So that first row of 5, -1 is going to become our first column. Okay, and then similar, the second row is going to become the second column. Okay, so there's AB transpose. All right, and then finally, the last thing they'd like us to calculate is B transpose A transpose. That's another matrix product. Okay, so let's see, what would B transpose be? Well, here's B at the top of the page, so we just need to reverse the rows and the columns. So that's going to become 1, 2, -3, and -1, 0, 1. And we'll take that and multiply it by the transpose of A, so take that matrix A and turn it on its side. Okay, and now we're going to do ordinary matrix multiplication like we did before. So if you want, feel free to pause the video here and maybe do this matrix product yourself if you're comfortable with it. Okay, welcome back. So hopefully you gave this a try. I'm going to run through it just to give you one more example of multiplying 2 matrices. We won't do this in the detail that we did the first one, but again, it's about taking rows times columns. So we'd start by taking the dot product of the first row of B transpose times the first column of A transpose, and if we kind of go across the row and down the column, we're going to get, let's see, 1 times 0, that's 0. And then 2 times 1, that's 2. -3 times -1 is 3. Okay, and I'm going to do the other entries a little bit more quickly. Okay, so we'd move on to this row times this column, and let's see, that's -1 times 0 is 0, plus 0 times 1 is 0, plus 1 times -1 is -1. Okay, and I'm just going to read the rest aloud here. Okay, then so this row times this column, and sorry, I know this is cluttered, but 1 times 2 is 2, 2 times 0 is 0, and the -3 times -2 is 6. Okay, and then finally, last one, you can confirm this, would look like that. Okay, and if we simplify that, we're going to get, let's see, 0 plus 2 plus 3 is 5, 6 plus 2 is 8, -1 and -4 it looks like. Okay, now I have a question for you. Do you notice anything interesting if you look at our last 2 calculations here? Well, notice that AB transpose and B transpose A transpose, we got the same matrix. Okay, that calculation was the same. And so, interesting observation that turns out to be true in general is that AB transpose is equal to B transpose A transpose. Okay, and that concludes this video. In the next video, we will give a formal definition of matrix multiplication.